Welcome back to the ZORI'S Physics and Mathematics live coaching. And today we are going to see the question number 5th from your exercise 1.3. Before going on this question, I have to tell some things to you. Very first, all these questions are very important for your 12th class board examination. So all you students repeat these questions time to time at your home, and most important thing, so many students are responding us, that means they are looking our videos, and I am requested then please subscribe our channel for the next more videos here. So move on the next question here, that is question number 5. In this first sub question is, if log x plus y, it is equal to log x into y plus p, where p is a constant, then we have to prove that dy upon dx it is equal to minus y square upon x square. So this is our question. So let us start this question here. First, this given part we have to write down here, that is log x plus y is equal to log x into y and that plus p. After this, differentiate with respect to x here. Differentiate with respect to x. So what happens here? Derivative of log, 1 upon x plus y is the derivative of log, that is into d by dx of x plus y, that is equal to 1 upon x y. This is the derivative again log into d by dx of x into y, and plus derivative of p is 0 because p is constant. So this is your first step. Move on the next step here. Take the derivative of these two terms. So 1 upon x plus y in bracket, derivative of x, that is 1, and derivative of y, that is dy upon dx, that is equal to 1 upon xy in bracket. This is product here, so use the product rule. So we have x into dy upon dx plus y into d by dx of x. Now multiply this bracket, 1 upon x plus y plus 1 upon x plus y into dy upon dx. We multiply by this term to the 1 and dy upon dx. So that is equal to, here also, 1 upon xy in bracket x into dy upon dx plus y. Now here also we have to multiply. So see here, 1 upon x plus y plus 1 upon x plus y into dy upon dx is equal to 1 upon xy into x into dy upon dx plus 1 upon xy into y. So here we multiply this bracket with this term here. So we cancel this x with x. We cancel this y with y. So 1 upon x plus y plus 1 upon x plus y into dy upon dx is equal to 1 upon y into dy upon dx plus here 1 upon x. After this, we have to shift this term here and this term to the right here. So 1 upon x plus y into dy upon dx minus this term here. So 1 upon y into dy upon dx is equal to 1 upon x minus 1 upon x plus y. Here we can take common dy upon dx. So in bracket 1 upon x plus y minus 1 upon y is equal to 1 upon x minus 1 upon x plus y. After this, we have to do these two subtractions. These two subtractions we are doing here. Therefore, dy upon dx in brackets here y minus x minus y. Right? This is y here, x plus y here. So this minus makes the x minus and y minus. And finally, y in bracket x plus y. After this, that is equal to here also x plus y, and this minus x total divided by y in bracket x plus x in bracket x plus y, this product. Now after this, dy upon dx in brackets here we cancel this y with this y, here we cancel this x with this x, and here also we cancel x plus y in the both sides here. So finally what we remain with? Here we remain with minus x upon y, that is equal to y upon x. So finally this y here in the multiplication and this minus x here in the multiplication. So finally we show that dy upon dx, that is equal to y into y. So this is minus and plus minus first, y into y square divided by x square. So finally we prove this here. Let us move on to question number 2 here. Before going on the question, we first understand the very important rule of logarithm, that is log base a of m, that is equal to m, that can be written as m is equal to a to the power m. Right? So this is the rule of logarithm here. If such a term in the logarithm is given, that can be written like this, that m it is equal to a to the power m. Now see, our given expression is also like this. So first we write this equation here, log base 10 of x to the power 3 minus y to the power 3 divided by x to the power 3 plus y to the power 3, that is equal to 2. So as per this rule here, we can write x to the power 3 minus y to the power 3 upon x to the power 3 plus y to the power 3, and that is equal to base, that base is 10 here taken and its power is 2. So that is equal to 100, right? The 10 square it is equal to 100. After this, we do the cross multiplication here. So x cube minus y cube, that is equal to 100 x cube plus 100 y cube. After this, we are taking this y cube to the right and this 100 x cube to the left here. So x cube minus 100 x cube, that is equal to 100 y cube plus y cube. 100 x cube here, then what remains here? See, minus 99 x cube, it is equal to 101 y cube. Therefore, y cube it is equal to minus 99 upon 101 x cube, Now at this step we have to differentiate this. So differentiate with respect to x. So the derivative of this part. So first we write the derivative d by dx of y cube is equal to minus 99 upon 101 into d by dx of x cube. Take the derivatives here, that is 3y square into dy upon dx is equal to minus 99 upon 101 into 3x square into d by dx of x. Now after taking the derivative, again we have to solve this here. So see, from both the side we cancel this 3. So we remain with dy upon dx into this y square, that is equal to minus 99 upon 101 into x square. This derivative is 1. So this is x square here. Take this y square to the left here. Then we have dy upon dx, it is equal to minus 99 upon 101 into x square upon y square. So same thing we have to. Let's move on the question number 3. Same pattern we have given. Log base 5 x to the power 4 plus y to the power 4 divided by x to the power 4 minus y to the power 4, that is equal to 0. Then we have to show that dy upon dx, that is equal to 12x cube upon 13y cube. So same pattern is given here. So very first we write this equation below here. So that is log base 5 of x to the power 4 plus y to the power 4 divided by x to the power 4 minus y to the power 4, and that is equal to 2. So by the previous rule here of the logarithm, we can write x to the power 4 plus y to the power 4 divided by x to the power 4 minus y to the power 4, and that is equal to base is 5 and its square. So 5 square, that is 25. Make the cross multiplication here. X to the power 4 plus y to the power 4, that is equal to 25 x to the power 4 minus 25 to the power y to the power 4 here. Now this y we have to take here, so that is 25 y to the power 4 plus y to the power 4, that is equal to, this we shift here to the left. Then 25 x to the power 4, we shift this here, so we have minus x to the power 4. So finally this becomes 26 y to the power 4, and that is equal to 24 x to the power 4. 25 minus 1, that is 24. So finally y to the power 4, that is equal to 24 upon 26, that is 12 upon 13, and x to the power 4 here. We simplify 24 and 26 here in the fraction. So we have 12 upon 13 here. Now differentiate with respect to x. Differentiate with respect to x. So we have the derivative of this part. I will write the directly derivative here. That is 4y cube into dy upon dx. That is equal to this 12 upon 13 as it is. The derivative of this part, that is 4x cube. Okay. Now here we cancel this 4 with the 4 and take this y cube here. So finally we get dy upon dx, that is equal to 12 x cube upon that is 13y cube, and same thing we have to show that. So that is very easy again. Now look at the question number, next question here. If e to the power x plus e to the power y, that is equal to e to the power x plus y, then show that dy upon dx, it is equal to minus e raised to power y minus x. So that first we are taking this equation here, e to the power x plus e to the power y, that is equal to e to the power x plus y, and this is equation number 1. Now differentiate with respect to x. So see what happened. Directly we are taking derivative of e raised to x is that is e raised to x here, plus derivative of e to the power y, that is e to the power y into dy upon dx, that is equal to the derivative of e raised to x plus y, that is e raised to x plus y into d by dx of x plus y. Now e raised to x plus e raised to y into dy upon dx is equal to e raised to x plus y in bracket. Derivative of x 1, derivative of y dy upon dx. E raised to x plus e raised to y into dy upon dx is equal to e raised to x plus y plus e raised to x plus y into dy upon dx. Now shift this term to the left here. So e to the power y into dy upon dx as it is here, this term here, and take this term to the left. So minus e to the power x plus y into dy upon dx is equal to this term as it is to the right, that is e raised to x plus y. Take this term here. So minus e to the power x. Now take common dy upon dx. So dy upon dx in bracket e to the power y minus e to the power x plus y is equal to e to the power x plus y minus e to the power x. Now take this term to the denominator here. Therefore dy upon dx is equal to e to the power x plus y minus e to the power x divided by e to the power y minus e to the power x plus y. After this, from equation 1 we are substitute here e raised to power e raised to x plus y. In place of this, from equation 1 we substitute e raised to x plus e raised to y. So from equation 1, remember e raised to x plus y can be written e raised to x plus e raised to y. So here in the place here and here we are putting the value. So we have dy upon dx, that is equal to first e to the power x plus e to the power y minus this e to the power x divided by e to the power y minus e to the power x minus e to the power y. So cancel these terms here, this with this and this with this. So we have dy upon dx, it is equal to, remember here remains with only e to the power y in the denominator minus e to the power x. So when we take it is in the numerator, so we have minus e to the power minus x. Remember this term, that is minus e to the power x, it is in denominator, so we take it in numerator, so its power become negative. Now minus e and power, that is y minus x we can write. So dy upon dx is equal to minus e to the power y minus x. That finally we now look at the question number 5. So here in the question, sine inverse of x to the power 5 minus y to the power 5, that is upon x to the power 5 plus y to the power 5, that is equal to pi by 6 here. That means 30 degree. Then we have to show that dy upon dx is equal to x raised to 4 upon 3y raised to 4. So first we shift this sine inverse here. So we have x to the power 5 minus y to the power 5 divided by x to the power 5 plus y to the power 5, that is equal to sine of pi by 6. Sine pi by 6, it have a value that is 1 upon 2, because sine 30 from our table we have its value is 1 by 2. Now do the cross multiplication. This 2 multiply here, so we have 2x raised to 5 minus 2y raised to 5 is equal to x raised to 5 plus y raised to 5. Then this 2y raised to 5 to the right and this x raised to 5 to the left. 2x raised to 5 minus x raised to 5, that is equal to 2y raised to 5 plus y raised to 5. As we do this subtraction, we have x raised to 5 and that is equal to 3y raised to 5. Therefore, finally we have y raised to 5, it is equal to 1 by 3 x raised to 5. Now here we can differentiate. So differentiate with respect to x. So we have 5y raised to 4 into dy upon dx, it is equal to 1 by 3 into 5x raised to 4. The derivative of this part, x raised to 5, the derivative of x raised to 5, that is 5x raised to 4. Derivative of y raised to 5, that is equal to 5y raised to 4 into dy upon dx. So finally take this part here, or first we cancel this 5 here and then we take here. Then final answer that we get here, dy upon dx, it is equal to that is x raised to 4 and this 3 into y raised to 4. So finally same thing we have to prove here. So in this way we cover 5 questions from the question number 5 here. I hope all you repeat these questions at home, and if you like the video, please subscribe our channel. Thank you.